Welcome to the second lecture in the series of lectures on functions of a real variable. The title of our lecture is Definition and Identification of Functions. I am your lecturer, Professor E.O. Efanga. Definition 1. A function from a non-empty set A to a set B is a rule F that maps every element of A to a unique element of B, that is, to one and only one element of B. Let us use diagrams to illustrate this definition. Let us look at this diagram. Here, one element in A is mapped to two different elements in B. This is not allowed in a function. Now, let us look at this other one. Here, two elements in A are mapped to a single element in B. This one is allowed. Definition 2. A function from A to B can be viewed as a special type of binary relation between A and B, in which no two ordered pairs have the same first element. Example 1. Consider a map F from A to B in which A is a set of element A and B is a set of element 1, 2. Then the relation defined as follows: F equal to the set of pairs A1 and A2. This relation is not a function because, as we can see, these two pairs have the same first element, AA. Example 2. Consider a map F from A to B in which A is the set of element ABC and B is a set of element 1, 2 to 9. Then the relation defined as follows: F equal to the set of pairs A1, B4, C9. This relation is a function from A into B. Let us view this in a diagram. Here A is mapped to 1, B is mapped to 4, C is mapped to 9. So as you can see, every element in A is mapped to an element in B. Hence, F is a function from A into B. Example number 3. Consider a map F from A to B in which A is a set of element ABC and B is a set of element 1, 2 to 9. Then the relation defined as follows: F equal to the set of pairs A1, B4. This relation is not a function from A into B. Why? Because one element here, one element in A, is not mapped to element in B. That is element C. Here A is mapped to 1, B is mapped to 4, but C is not mapped to any element in B. Let us look at this in a diagram. A is mapped to 1, B is mapped to 4, but C is not mapped to any element in B. That is why the rule F is not a function from A into B. Example 4. Consider a map F from A to B in which A is the set of element ABC and B is the set of element 1, 2 to 9. Then the relation defined as follows: F equal to the set of pairs A1, B4, C9, A9. This relation is not a function because observe that this pair A1 and A9, they have the same first element. That is why it is not a function from A into B. Let us look at this in a diagram. Here is A that is mapped to 1, and at the same time it is mapped to 9. So clearly f is not a function. Example 5. Again, let us consider a map f from A to B, in which A is a set of elements A, B, C, and B is a set of elements 1, 2 to 9. Then the relation defined as follows: f equal to the set of pairs A1, B4, B9, C6. This relation again is not a function, because as we can see, these two pairs have the same first element, BB. Let us view this in a diagram. A is mapped to 1, but B is mapped to 2 elements, mapped to 4 and to 9. Hence, f is not a function from A into B. Functions in expression form. Let f be a function from A to B if an element x of A is mapped to an element y of B. We say that y is the image of x under f, and we write this. We read this as y is equal to f of x, or y is a function of x. Example 6. Find the image of 2 under the function f of x equal to x squared plus 4x minus 3. Solution. To find the image of 2 under this function is to put x equal to 2 into the expression, and this will give us f of 2 is equal to 2 to the power 2 plus 4 times 2 minus 3. This is equal to 4 plus 8 minus 3, and that will give us 9. So the image of 2 under f is equal to 9. Example 7. If f of 0 is equal to 6 and f of 3 is equal to 45, find the values of f and c in this function. F of x equals to 3x squared plus bx plus c. Solution. Since f of 0 is equal to 6, let us put x equal to 0 into the expression to obtain f of 0 equal to 3 times 0 squared plus b times 0 plus c, and then equate that one to 6. 0 squared is 0 times 3 is 0, b times 0 is 0 plus c. So that will give us c equal to 6. Now for f3 equals to 45, we put x equals to 3 into the expression, and that will give us f of 3 equal to 3 times 3 squared plus b times 3 plus 6, that's plus c, which is 6, and that is equal to 45. That is 3 squared is 9 times 3 is 27 plus b times 3 is 3b, then plus 6 is equal to 45. 27 plus 6 is 33. Take it over to the right hand side. That will give us 3b equals to 45 minus 33, which is equal to 12. If 3b is equal to 12, dividing by 3, we will obtain b equals to 4. On your own, find the image of x equals to 3, minus 1, 2, and 5 under the following functions. 1. F of x equal to 5x squared minus 3x plus 2. 2, f of x equal to 1 all over 2x plus 1. 3, f of x equal to the square root of 6x plus 10. We have come to the end of lecture 2. Thank you for watching and keep on watching.